All right, hello everybody. This video is going to be just a quick rundown of the AP Classroom 15 question multiple choice that I had you do yesterday. And I'll go through these fairly quickly. If you have questions, you could get in contact with me, but if you need to rewind or pause or stuff like that, I will leave that to you. Question number one, we'll start with: what are the values of k for which this series converges? We've got something to the n power. So it is a geometric series, which means if that number, whatever it is between -1 and 1, exclusive, then it will work. So to do this one, it does say that we'd be allowed to use a calculator on this one. So I just took this expression and plugged it into Desmos. You could use your graphing calculator for this also. But here it is, k cubed plus 2 times e to the negative k. And if that quantity is between -1 and 1, this will work. So I graphed between -1 and 1, and looks like we've got a range of values, a very small range of values over here between, well, hard for me to see exactly. We'll have to look at the multiple choice options. And then everything greater than 4 point something, hard to tell, 4.6 or 7 or something like that. Obviously, on a calculator, you get more precise than what I am getting just by looking at it visually, but looks like this is the one, a small window around -1, and then for values of k that are bigger than 4.596. I'm going to lock in for that one. Question number two: if S sub n is the nth partial sum, and n is bigger than 3, so basically we're looking down the line a few terms, and it's all in terms of the partial sums. So this term, the nth term, is which of these partial sums? So when I thought about this one, I said that the nth partial sum is the partial sum that came before that plus the nth term. And then we are just one quick little algebraic rearrangement away from saying that this one must be the answer. The nth term is the nth partial sum minus the previous partial sum. Little review of terms there. Question number three. Let's see if c is a positive real number. The terms are something times natural log of c. For what values of c does it converge? Well, if k is going from 1 to infinity, k is getting to be a really, really, really big number. In order for this to converge, in order for any series to converge, the terms have to be going to 0. And if k is getting infinitely big, if the natural log of c is anything other than 0, eventually, even if it's a very, very small value, eventually a very, very large value of k is going to overpower that. So we just need for the natural log of c to be 0, period. So if the natural log of c is equal to 0, c must be equal to 1, and that is the only one that's going to make any sense there. Question number 4. Let's see, we've got a sequence of real numbers. Let's see, the nth term of this series is the nth term of some other series minus the previous term. This one actually had me confused for a little while. I had to read it a couple times to really understand what it was asking, and I didn't really have a solid answer. I was looking at options B and D. Both of these possibly made sense. A word about option A: this is never good logic. If the limit of the terms is equal to 0, then the series converges. Don't go with that. That is a total trap option. But when I started listing off, I just picked 19 for no reason in particular, but just to say that according to this, the nth term of A series is the nth term of the B series minus the term before that for the B series. So the 19th term of the A series is the 19th of B minus the 18th of B. And so if this is the 19th term and the 20th term and the 21st term, if we were adding these up, we've got a b sub 19 minus a b sub 19 and a b sub 20 minus a b sub 20, and that b sub 18 is going to get subtracted from another b sub 18, and this one's going to get subtracted, and this actually starts to feel like a telescoping series where all the terms are going to go away except for that very first term that would be up here somewhere, and then the nth term dragging along down there. But they do tell us, or they give us as an option, if the nth term of the B series is a finite real number, basically saying that that last term is a finite real number, it's not infinitely big, um, then it's going to converge to something. We're not sure what it converges to because it depends what that first term was, but um, I think the answer is B. The answer of D, we actually are evaluating what it's equal to, and I think there's too much that we don't know to do that. So I believe the answer is B. I'll check on that and make sure that that's okay and let you know if that is wrong. I'm taking too much time. I thought I was going to be quick. I'll try to speed up. Question number 5. A is a non-zero real number. R is a real number between 0 and 1. This is feeling like a geometric series. These look like geometric series. In fact, they look exactly the same, except one of them starts at 0, the other one starts at 1. So the only term, the difference between these two, is that 0th term. So n equals 0, plug that in here, a times r to the 0 power, that's a times 1. That's a. The only difference between these two is the first term of one of the series, which is a. Moving right along, question number 6. Let's see, they tell us that x times y is between -1 and 1, which means we're looking at a geometric series. So I just went straight to the geometric series formula. The sum of an infinite number of terms in a geometric series, as long as the ratio is less than 1, is the first term. That's what I get when I plug in n equals 1 divided by 1 minus the ratio. And fortunately, there wasn't any simplification that I needed to do there. So my answer is C. Question number 7, everyone's favorite multiple choice question. Let's see what this says. If the a sub n series diverges, this is just telling us what a partial sum is, the sum of the first n terms, and the limit of the terms of b is not equal to 0. I'm going to start with that. If the limit of the terms is not equal to 0, that means that that series does diverge, so that is definitely true. Let's see, this just says it's the partial sum, so that doesn't tell us too much. If the series diverges, this is a question mark. Maybe the terms are going to 0, maybe they're not. We don't know, but the sum, or the nth partial sum limit, does not exist. That's the definition of what it means for the series to diverge. So what am I going with? 2 and 3 are my answers. Question number 8. The nth term is the nth root of 2. So it's the first root of 2, or 2, the square root of 2, the cube root of 2, the fourth root, the fifth root, the sixth root of 2. And if you know the behavior of roots of numbers bigger than 1, it's 2 and then about 1.4 and then something a little bit less than that. But as we look at higher and higher and higher powers, those are eventually approaching 1. So if the terms are not approaching 0, I don't know if that makes sense, but that is my way of saying that these terms are not approaching 0. Let's see, series diverges, the limit of the terms is not equal to 0. I'm going to go with that one as my answer. Terms don't go to 0, the series must diverge. Question number 9, the nth term test, which is what I just used for question number 8. If the terms are not going to 0, then the series must be divergent. Inverse tangent, you might have to brush up on unit circle trigonometry and look at if n is going to infinity, the inverse tangent of n is approaching pi over 2, which is not equal to 0. So we could apply that nth term test to option A to say that that is a divergent series. This one, well, the terms are going to 0, so the nth term test is inconclusive. We know that this is a geometric series, so this one converges, but the nth term test is not telling us that. Convergent. This is painful for you to watch as it is for me to write. You don't have to answer that. Option C, let's see, I've got a second degree polynomial on top and on bottom. Degrees the same on the top and the bottom. So I've got 1n squared and 1n squared. Ratio of the leading coefficients is 1. And since the terms are not going to 0, we've got another divergent series. And then finally, as n goes to infinity, the natural log of n is going to infinity also, going more slowly, but not going to 0. So the nth term test applies to these three. If the terms are not going to 0, then it is a divergent series. So that's the one that it does not apply to. Question 10, moving right along, the integral test can be used. So we'd have to look at the integral from 1 to infinity of x over x squared plus 1. Almost feels like an inverse tangent antiderivative, but this is the substitution. Let u be the stuff on the bottom. Du is 2x dx. You're a little manipulation away. When I did this one, I evaluated it. You end up with a natural log of, it's like 1/2 times natural log of x squared plus 1, I believe, which as n goes to infinity, that is going to go to infinity, which means the series diverges. The terms are going to 0. These terms are getting smaller and smaller and smaller as n gets bigger and bigger and bigger, but the series does diverge. So I believe we're looking at diverging, but the terms, oh shoot, no, the terms are approaching 0. So let's go with that. The series diverges and the terms have a limit of 0. Integral test says that if this integral is finite, if it exists, then the corresponding series does converge. Not to the same value, but it does converge. Question 11, integral test can be used to determine, okay, so this one, we would be able to integrate the corresponding integral for that one. This one, not too bad either. We'd end up with some kind of a natural log. This is a question mark for now as I'm looking at this problem, but I do not know how to do that integral. So as long as I can do this integral, and yes, we can do this integral, this will be a substitution. Let u be natural log of x, du is 1 over x dx, and that one cleans up pretty nicely. So it looks like this is the one that we do not know how to anti-differentiate, which means we cannot apply the integral test. Moving right along, question 12. This one looks familiar. The integral test can be used to conclude that which of these is true? Let's see. Oh, sorry, we can do this one. This is an integral that we can anti-differentiate. This is a good review for those of you who have gotten rusty with integration by parts. I would suggest that you take a look at how to do this integral using integration by parts. I'll set it up here for you, the corresponding integral. Instead of calling it x divided by e to the x, I'm going to call this x times e to the negative x, and that might help you if you want to go ahead and try integration by parts. When I did this one, I did find that this did exist. I don't remember what it existed as a value, but it did exist, which means the series converges. The terms must have a limit of 0, and that is true. I will leave it to you to go back and review your integration by parts. Question 13, which is divergent harmonic series, definitely a divergent series. P series with p less than 1 is divergent, and a p series with p bigger than 1 is not divergent. So it looks like we've got 1 and 2 as our answers there. Not too bad. Question 14, which is the alternating harmonic series. -1 to the n plus 1, that'll give us the plus minus behavior. And in the denominator, my answer is A, but I'll just take a look at the rest of them. This one's alternating, but it's not harmonic. Looks like we've got some kind of an alternating P series there. This one is alternating, but 5 to the n. This feels more like an alternating geometric series. And I don't know what this one is. I guess it's 1/5 of the alternating harmonic series. So if we call it the alternating harmonic, we'll have to go with option A. And then finally wrapping things up, which of these are the first 6 terms of a P series? We're looking for something of the form 1 over n to the p power. And so as I look at the first one, this looks like, well, it's alternating, so that wouldn't count as a p series. This one is the same, except it's not alternating. So I've got 1 over 1, and then 4, 9, 16. I recognize that these are squares. So this could be n to the first, n squared, n to the third, or sorry, I'm goofing up here. Let's see, this would be 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So that's looking like a p-series where p is equal to 2. That's looking like a pretty good candidate. I'm going to go ahead and circle that and then make sure that the rest of these don't work. Same denominators here, but the numerator's got other stuff going on. So this one looks more like an n over n to the p, or n minus 1 over n to the p, or something like that. Not exactly p-series. And then the last one, ooh, this one looks like it's geometric. Looks like each term is 1/4 of what the term was in front of it. This looks more like something like 1 over, I guess this would be 4 to the n, where n starts at 0. But that's geometric. That is not p-series. So it looks like my answer is B. I hope this was helpful. Um, whether you thought it was or wasn't, I would appreciate any feedback that you have. But that's it for this one. I will also be recording a lesson for power series that you should be looking at today as well. All right, that's it. I need to stop this thing.